Solve by completing the square. In part A, we have x squared plus 10x plus 22 equals 0. So here's your recipe for solving by completing the square. Okay, and this is when you have one variable. It's a one variable equation. It'll be a little bit different when there's two variables. So I'll put in parentheses one variable. Okay. So the first step is going to be isolate the constant. So what do I mean by the constant here? The 22. How could I get the 22 to the other side? So go subtract 22 from both sides. And then you have x squared plus 10x. Leave a little space between the 10x and the equal sign. Equals negative 22. X squared plus 10x is equal to negative 22. Okay. The second step. Now, the second step's not relevant here, but it will be in the next problem. You're going to want to divide through by the lead coefficient. So what's the lead coefficient in this case? 1. So does dividing by 1 do anything? No. But the point is you need a 1 in front of the x squared before you complete the square. So what do I mean by complete the square? Okay, think of the last example, you guys. The reason the last example worked is because of this plus 36 here, right? X squared minus 12x plus any other number would not factor to be the perfect square x minus 6 quantity squared, would it? It wouldn't work. So the idea is we're going to find, so pretend like we were just given, on the left side, we were just given x squared minus 12x to start with. We're going to find, if we didn't already know it, in this example, we're going to find the appropriate number to add so that you get a perfect square. And so we can factor it and solve it like we did in part D. That's what we're trying to do here. That's solving by completing the square. Now, it won't be 36 here, but what we're trying to do is we're trying to find the number. Let's put it in a box. We're trying to find a number we can add here. So we'll put it in the box here. To make it so that we have x squared plus 10x plus something else, and that something else makes it a perfect square trinomial on the left side, so it factors to be some binomial squared. I want to make sure you know why we're doing what we're doing. We want to add something that makes it a perfect square on the left side. That's completing the square. And there's a technique for doing it that works every time. As long as you have a 1 in front of the x squared, what you can do is this. You can take half, well, let me write this down. This is step 3 in your recipe. Take 1/2 the coefficient of x. Now, it's not always x, but whatever the variable is to the first power, you're going to take that coefficient, in this case 10, and divide it by 2 or multiply it by 1/2, same thing. Take half the coefficient of x. That's just part of step 3. Okay, what's half of the coefficient of x in this case? What's 1/2 of 10? Yeah, it's the same as 10 divided by 2, right? If you multiply 10 by 1/2, you get 10 over 2. So you get 5. I want you to write that 5 down below this line that we're on. So write down 5. And really write down, because it's a plus right here, write down a plus 5. And then what we do with that to complete the square, to fill in the box, is we square it. Okay? So to finish off, well, I could fill in the box right now. We square 5. What do we get when we square 5? 25. So that x squared plus 10x plus 25 on the left side, that's your perfect square trinomial. In fact, what does it factor to be? Yeah, that's why I wrote down the plus 5 ahead of time. X squared plus 10x plus 25 factors to be x plus 5 quantity squared. Now, I changed the value of the equation, so what should I add to the other side as well in that step above? Yeah, so I should have added, maybe I should have done it right away, but at least I did it. To balance things out, you got to add 25 to both sides. So let's add it to both sides. Okay? Now that's step 3 completed on the problem, but I didn't actually complete the step in the recipe here. So we take 1/2 the coefficient of x. That, when you say 1/2 of the coefficient of x, it means multiply. Or divide by 2, same thing. And then what do? We square it. So we take whatever that is, we take 1/2 the coefficient of x, we square it, and add it to both sides. And that completes step 3. That's the really important step where you're completing the square, step 3. Okay, step 4. So step 4 then is to just solve by taking roots. Yeah, you got to simplify first, but solve by taking roots, just like we did in the previous examples. Okay, so back to the problem. We have x plus 5 quantity squared on the left side. Simplify it on the right side. What do you have? What's negative 22 plus 25? 3. Okay. So we're kind of back where we were in part D then, right? Or the second step of part D, that is. What do we do to both sides to get that exponent of 2 off the quantity x plus 5? That's step 4. We solve by taking roots. What do I need to remember in front of the square root of the 3? Plus or minus. Okay. And so we get x plus 5 is equal to plus or minus root 3. Oh, okay. Now I can't combine 5 and root 3 in exact terms, right? So there's no reason to separate the plus and minus here into 2 different equations. Let's just isolate the x. How do we do that? So subtract 5 from both sides. And the best way to write it then would be, of course, x by itself on the left side, and then negative 5 plus or minus root 3 on the right side. Negative 5 plus or minus root 3 on the right side. And so those are 2 different answers, negative 5 plus root 3, negative 5 minus root 3, 2 different answers in exact form. Now it might be nice to get a decimal approximation of both of these, right? So let me show you how to do that real quick. Okay, let's do the one with the minus. So you would go negative 5 minus the square root of 3. So then use the negative button, not the minus button, the negative button to the left of the enter button if you have a TI calculator. Negative 5 minus, okay, second function x squared, get you the square, whoops. If you press the right button, second function x squared gets you the square root, and that's a 3. Press enter, and you get about negative 6.73. Now remember, your calculator is powerful. You can store this number. I've shown you that before, right? Have I? Yeah, I think I did. So hit STO on your calculator if it's right above the on button if you have a TI 83 or 84. It might even be that way on the TI 30 as well. And then store it as x. X is this value up here. When you press this button right here, store it as x. Now every time you hit x, that value is going to come up. Why is that so powerful? Well, now you can just type out the left-hand side of the original equation and see if you get the right number. So the original equation was x squared plus 10x plus 22 equals 0, right? So now when you type that in your calculator and hit enter, you better get something either 0 or really, really, really close. So let's do that, and that's a way to check your answer, by the way. So now I'm going to type in x. Okay, hit the x squared button, plus 10x plus 22. And if I'm right, I'll get something really close to 0 or actually 0. So there you go. Now that's really powerful, you guys, because that means you can check your answer on the test easily, right? You don't even have to do it by hand. You have to do the problem by hand. If you don't show your work, you're not going to get any points. But you can check your work. You can go home knowing whether or not you got the right answer. So if you hit second function enter, you'll get back to how we calculated x. So it was -5 minus root 3. And that was -6.73 if we round off. So it's good to be able to get exact answers and approximations. So x is approximately -6.73. And by the way, on the calculator, if you don't want to type -5 minus root 3 and over again, just hit second function enter, arrow over, and change that minus to a plus to get the other solution. -3.27 if you round up. And these are approximate, right? So this is exact. The one with -5 plus or minus root 3 is exact. These guys are estimates. They are approximations. Know how to get both.